Hello everyone, I am Wu from X Discovery Lab at Dartmouth College. Today I am going to present the work, Proxino, enabling prototyping of virtual circuits with physical process. This work is advised by Xing-Dong and in collaboration with Gong and Seyed. Whether you are a maker or a researcher or a person teaching different concepts in electronics, circuit prototyping is super common. Often, you will use a breadboard, but physical breadboards can be hard for novice user because components and help can be limited. On the contrary, software-based circuit prototyping has a number of powerful features that will be much easier because there isn't as much of a reliance on physical components, as you can see in this video. So a user has an unlimited inventory of the components that can be put on a virtual breadboard. And to tune the values, just do it in the drop-down list, so it's very quickly. And the pirate worker such as auto-freeze has enabled auto-completion for virtual circuits, making it very easier for novice users. For example, if we put a LED, a series resistor will be auto-completed. In terms of help, software such as Autodesk circuits allows for remote collaborations. This makes it easier for people with different levels of experience can share and learn and collaborate the circuits together. But despite many of the benefits I mentioned here, there's still one main challenge. That is the disconnection between the virtual circuit and the physical world. This means that although a user can build a circuit in the software, they cannot physically interact with it. So for example, a user can build a circuit with a motor to generate the wind, but they are unable to feel the wind coming from the motor. So to solve the disconnection problems, we create Proxino. It allows the user to create virtual circuit and interact with them both virtually and physically. So at a high-level concept, it works as follows. Once a virtual component is linked to a physical component, any change on the physical component is reflected on the virtual component, so that the virtual component behaves as is in the physical world. Next, I would like to describe how to use the Proxino. Using Proxino is very simple. A user first develops a circuit, a customized version of the freezing. Freezing is a popular circuit diagramming tool. When users want to set out a physical process, they can simply set out the physical process for virtual component and insert the real one component into our shell. Again, link the component and insert the real one. Proxino also supports Arduino programs, so similar to the Arduino IDE, code can be also written and uploaded directly in the freezing. So to physically interact with the circuit and its components, a user click the run buttons and they are able to physically interact with it. In the previous example, I showed you a simple one. So now I can show you a more complicated circuit. It includes the transistor and a motor. And similar to the previous example, a user can build a circuit on the software and link the component to physical process and insert the real one component into our shell. Again, link the component for output device. And then finally, the users can feel the wind strength coming from the real motors. So they don't use the transistor or resistor to build a physical circuit, they can just use the component they want to interact with it. So Proxino is extremely useful in a scenario where you don't have a component or you are missing component need to test in your circuits. Or when you need help when a circuit is not understood. This type of scenarios are enabled when a virtual circuit can be shared over the internet By making it sure, user can remotely collaborate and build circuits and physically interact with it together. What's more interesting, we can think about the physical resources such as a component and the environment could be shared over the internet. So coming back to the scenario where a user needs help, a user can so her friend can remotely modify the circuits and to teach different concepts. As a user doesn't have a component, the remote user can physically interact with it. And the circuit prototyping also doesn't have to be done in home, in makerspace, or in laboratories. Often we may spend a lot of time traveling on a bus. So currently it's impossible to carry the physical component and the variable on the ride, right? But sometimes we just want to test our idea very quickly. I know it's somehow awkward now, but with Proxino, it becomes much easier. We do this by using the built-in sensor of the tablet as a physical proxy to virtual components. So this lets the user to prototype and interact with the circuit ubiquitous just with the tablet. So for example, a user can link a virtual photoresistor to a built-in ambient light sensor, and which lets them physically interact with it, as though the component were real. Similarly, the built-in proximity sensor can be used to detect distance that was linked to distance sensors. Next, I will describe some of the detail about how we implement the Proxino. At a high level, Proxino updates the electrical properties of physical components with those of virtual components. This means, for example, that the physical resistance of a photoresistor is updated with the resistors of a virtual component. So any change in the real environment is then reflected in the virtual component. In this way, it runs as a real circuit. So to achieve the link between physical and the virtual component for Proxino, we built a custom Arduino shroud. This shroud is able to directly mount on the Arduino. The custom shroud handles the communication between the electrical properties of the different physical components connected to it. It can measure the resistance, capacitance, and the switch status and the voltage from a real component and send it to the virtual component. And then the virtual circuits run in a simulator to compute the circuit behavior. Once this is done, it sends back the calculated output voltage to the shroud, which then drives the output physical process like LED to blink. Next, let's discuss how Arduino program works in this flow. A typical Arduino program usually have some reading and writing functions. If a reading function is called, the compute input voltage is then returned to the programs. And then the programs continues. And if a writing function is called, the output voltage is sent to the virtual circuits. And after calculation, the final output voltage then returned to the shroud, which then drive the physical process. So as you can see, the steps in the system for Arduino are very simple. Next, I'm going to talk about our shroud. So far, I have described examples such as a circuit with a photoresistor, where data is acquired from physical process. But a photoresistor is usually in serial with a resistor. And you may have noticed that we are not using any one. So the question is, how do we read the resistance or other electrical properties from the real components? So to solve this problem, we developed two circuits, a data acquisition circuit and a Proxy driver circuit. The data acquisition circuit has 8 pins. Each pin is capable of measuring voltage, resistance, capacitance, and switch status from the input components. It consists of a DAC, a digital potentiometer, an amplifier, and a ADC. Yeah. And then the Proxy driver circuit also has 8 pins, which generates analog signals voltage up to 6 volts, and a current up to 500 milliamperage for different type of output components, such as LED, motors. So far, I've described how Proxino works with physical process. But now, let's go deeper into how the virtual circuit runs on the software side. First, we use the freezing to allow users to build the virtual circuits. In addition to its existing features, we include the ability to remotely access virtual circuits. This means that the multiple users can modify a circuit now. So here you can see there are 3 users. To synchronize the circuits and the data from different remote users, we develop our custom servers. We also modify an open source real-time circuit simulator called LabSpice to compute all circuit behaviors that a user could perform. The results of the circuit simulator are returned to our custom network server, and the entire software system handles the synchronization between the shard and the user programs and the simulator results. So now we can see how our system works. So to test our system and get some initial feedback for Proxino, we conducted an informal user study. In this study, we asked 9 participants to create a nighttime circuit in a desktop environment and in a car and with remote collaborators. Using a qualitative method, we get some interesting insight. First, many participants comment that Proxino allows them to use a fewer physical component and a jump wire to construct a circuit while still being able to interact with it physically. This means that it enables them to focus more on the circuit design. And in the mobile scenarios, all participants find it handy to use the tablet built-in sensor as a process. One of the participants commented that they can simply take their circuit and show it to others without carrying others' hardware components. So for remote collaborations, several participants were very excited that collaborating our physical circuits now become possible. Though some of them also comment the communication between the remote user could be improved. Well, I already explained most of Proxino. I haven't explained where it fits in the current literature or what's the following our work. Using software to help physical circuit prototyping has been proposed several times. For example, Tosbor from Beyond Hotman Group and Circuit Stack, this is my previous work, are just 2 examples demonstrating how to help users in prototyping physical circuits with software features. And in UIST 17, I present current vis and circuit sense in Quebec City, which respectively contribute to visualizing components and their electrical current on our virtual breadboards to help users debug, share, and learn about physical circuits. And as some following work, scanner log and virtual components, they were all dedicated to make the virtual and physical environment to help physical circuits. Different from the previous work, Proxino fully blended the virtual and the physical prototyping. By using the physical process, it allows users to use all of the software features but can physically interact with the circuits. With the novel application scenario enabled by the Proxino, we believe that Proxino can change how everyone can learn and make physical circuits. We foresee that in the future, makers or kids will practice circuit prototyping mainly on the software and using Proxino to physically interact with it. So in the end, I would like to conclude our work with some take-home messages. So first of all, we present an interface blending the virtual and the physical circuits prototyping by using real I/O component as physical process. Second, we implement a Proxino prototyping, constant audio shot, and freezing. And we conduct an informal user study to show the usability of our tool. So thank you for everyone for listening. I'm happy to answer any question, and please feel free to email me.
Hi, this is Andrea Bianchi from KAIST. So very good talk. I'm curious a little bit about the realism on your output side. So you mentioned on your input, you actually look at the resistance, you look at the capacitance, but what about on your output side? I was checking out the paper, it seems like you have a buffered output, so you have a very low impedance, so you're not really simulating exactly what your circuit is doing, right? So can you comment on that?
Actually, output side is totally about voltage. So if you output enough voltages, the current and the impedance will be real, will be like a virtual circuit. So I mean for the output side, it's totally about voltages. So if you output the correct voltages, everything will be right.
Thank you.
So you mentioned both of your participants were very excited about this kind of ability to have an internet-mediated virtual circuits, right?
Yeah.
And yet I still am having a little trouble kind of writing a design fiction for myself where I would use that ability that your technology enables. Can you tell us a little bit more about how you see that being used?
I will see that in the future, like the makers, they will build the software circuits, and then they use the Proxino, and because of Proxino is the Arduino shell, so it can directly mount on the Arduino. So and Arduino is very common for makers. So basically they just need some components which is interactive. And then other components such as resistor or capacitance, something like LED or transistor, they don't need. They just build the software. They just build the virtual circuit. And because I also believe in the future the circuit simulator could be stronger. So when a simulator can simulate a real circuit, I think nobody will use the physical circuit again. Yeah.
Provocative thought to end on. Any other questions? All right, well, thank you very much for coming. Let's thank our speaker again.